Okay, so I'm live here with another live stream that's going to go into a series on enterprise ML ops, and I'm here with is it Maxime David? Is that correct?
Yeah, Max, you can call me Max. That's perfect.
Max. Okay, great. And I think where we connected earlier was you had published a really interesting uh, analysis of the the startup time for Lambda. And so I'm a huge fan of AWS Lambda, but I'm also a huge fan of thinking about the future in terms of what are some optimizations that we can do for performance. And so that's how we really connected. And then I thought, hey, let's just talk a little bit about Rust in particular. And yeah, maybe you can start off by giving people your background,
Sure.
and then maybe talk a little bit about what led you to create that chart, which is a really cool chart.
Yeah, definitely. So, hi, my name is Max. I'm living in Montreal, in Quebec, in Canada. I'm a French guy, as you can hear by my French accent, but I try to get better. So I hope this won't cause much trouble. So yeah, I work as a software engineer in the serverless team at Datadog. Datadog is a monitoring company, and our main focus is in Lambda. So I use AWS Lambda a lot. And I was trying to, on my free time, to benchmark some runtimes. Like, we know that when the Lambda function is starting, we have this cold start time, which is time that customer and users are paying for, obviously nothing, because it's just the time that a function takes to wake up. And there are a lot of different blogs where you can see that Node.js is more performant than Python and so on. But all of those blogs, I found that it's kind of outdated, because it's done at one specific time, and then like maybe 3 months later, AWS has made some very good performance improvements depending on the runtime. So I was thinking about, oh, maybe I can create a bot which deploys overnight one hello world simple, very simple function to AWS infrastructure, and then ping them 10 times as a cold start, and then grab the init time duration, do a mean, an average, and just display the results. So overnight, every night of every day, you have like live benchmark of every runtime. So that's why I built the tool.
Okay. So you're even continuing to update this tool. So it's a real time, performance indicator across multiple
Exactly.
languages.
Yeah, and someone Tim, who wrote Rust in Action, was showcasing my tool. I think on Tuesday on Twitter, and this tweet went a bit viral. So I have a lot of stars and open issue already on the repo. So they asked for support for Dart, for like Java AOT, and so maybe Quarkus and GraalVM as well. So yeah, I guess I have to update for new runtimes on a
Ah,
rolling basis. So that's kind of exciting.
yeah. And what I'll do is when I publish this to other places, I'll put a link to to both your GitHub project, and
Yeah.
then also the URL where people can take a look at it.
Yeah, thanks for saying that, because yeah, the main point of this project, of course, is to detect a cold start duration across all runtimes, but it also show how to use serverless for a real use case. This is done only thanks to serverless technologies, and it's open source. And it's because when you do benchmark, of course, you want to see the code. What are you actually benchmarking? For Node.js, writing a hello world is like, there's almost only one way to do that. But maybe for Rust or Dart, there's some different libraries that I could use. So everything is super transparent, so everyone can have a look at what I'm doing and how it's working. If you want to fork it, create some PRs, contribution are very welcomed.
Great. And I guess what's kind of fun about with Copilot now, once you get some traction with, 3 or 4 languages, then if you want to translate, there's the Copilot Labs tool. Have you played with that?
Actually, I'm more into GPT-3, but
Okay.
it was kind of a long run project that I've been thinking for a long time, even before joining Datadog, actually. And so I use my own skills to
Ah,
code it. But
nice.
definitely, if I want to create like a Dart Lambda function, I know nothing about Dart, so I may ask for some help for either a Copilot or a GPT-3 for sure.
Nice. Yeah, and I think maybe we should summarize then what what did you learn by doing this? Like it sounds like there are some unique properties to Rust. Is that would
Yeah.
you summarize to people?
Yeah, definitely. So Rust is our award winner since the beginning of the tool. Maybe it will change with AOT of Java, GraalVM, maybe on Quarkus and GraalVM. Sorry, but yeah, for now, Rust is the great thing about Rust. It's a compiled language, of course, and the binary is super small. And I found that there is a strong correlation between the size of the binary or the dependencies and the cold start. So
Hmm.
as long as you keep your binary or your dependency very small, it will take less time to boot to start a new Lambda function. So the cold start will be very small. So obviously, if you're using a lot of SDK or, from different companies, your cold start will increase. And as long as your binary is really small, which is a case for Rust, I don't have the number in mind, but you can check on GitHub once again. This will impact the cold start in a good way.
Hmm. I was playing around actually just a few days ago with the ARM um, uh, version as well, and my experience has been it's very simple. I don't know if you played around with the Rust Cargo Lambda project. I think it's somebody from AWS where
Yeah,
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 it's pretty easy to deploy a Lambda, and you can deploy ARM as well.
yeah. That's a very good question. Actually, I'm a new YouTube creator, so I have my own YouTube channel, and I posted my very first video like 3 months ago about how to deploy AWS Lambda Rust in
Ah,
AWS. And I got a comment from, I think his name is David, who is currently supporting AWS Cargo Lambda. So yeah, I think it's someone from AWS. And yeah, it's really easy to boot a new Lambda function. You can even test it locally thanks to very handy commands. So yeah, this tool is great, and I've not tried deploying that with ORM, but it's definitely on my radar. I need to deploy that. And for now, the tool is only targeting US East 1, but definitely I should do that on at least one or two other regions, availability zone, just to make sure that the latency does not is not taken in account or is taken in account. I'm not sure. So maybe that benchmark would be useful as well.
yeah, that's yeah. I had zero issues with ARM, and the other thing that's interesting about Rust is that when you deploy to AWS Lambda, the speed is just so fast.
Yeah, yeah,
I mean, it's and I think what I really wonder about is that as someone who's used Python for decades, is that I think the idea that you should use one tool for everything, or that whatever worked in the past will work in the future, I think are very bad strategies for software engineering. I think it's important to be thoughtful about the fact that things always change. Like a really good example is the automobiles of the 1970s or the 1980s. Like I've been in like a 1970 Ford Mustang, for example. My friend in high school had one, and it was really interesting. Like, I mean, it has like 3 speed, and it would peel all the it would the tires would smoke, all through each 3 gears and everything. But you don't necessarily want to take a 1970 Ford Mustang and then make it an EV vehicle,
yeah,
right? Like, so I think with Python in particular, I think this idea that a 30-year-old language is going to always be the right choice is just, I think, a bad strategy. And I think what happens with software engineers is a lot of times you feel comfortable because that's what's popular now. It's like, oh, look, Python is popular now, like it's great. And then if you even bring up things like, well, wait a second, Python is the most energy inefficient language, or at least close to the most energy inefficient language like ever created. That's right. That couldn't we try something better, right? Like more of like just a hypothetical. So I don't know. What are your thoughts on basically like future, and how do you think Rust could play a role?
yeah. I think more and more people are adopting AWS because it's super easy to use and super fast to deploy. But one drawback that we've read a lot of on blog posts is this init cold start duration. because why not deploying your whole infrastructure on AWS? For some use case, it does make sense, and for some, maybe not. But with Rust, I believe that this inconvenience about cold start time is disappearing. So AWS Lambda is great, and Rust is great for that. And what I believe also is, if a Lambda fails, like obviously if software fails, that's not good. But it's even more true for AWS Lambda. And I believe that using Rust, which is very strongly typed, the compiler is great. You have a lot of guarantee at compile time. I think it's safer to use such language for AWS Lambda, because usually you deploy like maybe a 20 line or 30 line, maybe 100 line Lambda function, and it should be very serve only one goal. And by using like a very strong static checker to check whether or not your code is working, I believe Rust is really excelling in that. So I believe Rust is very good use case for AWS Lambda. And I think the tooling, we talk about AWS Cargo Lambda, sorry. It's a great tool, and I've read a lot of free resources to learn Rust on AWS Lambda. So I'm not sure how it will go over the long run, but I strongly believe that it's the right balance between like very hard to code like C, because obviously if you deploy a Lambda function in C, it might be even more performant. But no one wants to, not no one, but not a lot of people wants to maintain and unit test and deploy C code anymore. So I believe that Rust is a right balance between performance. It's obviously the learning curve is a bit steppier, but I believe Rust is a good choice for AWS Lambda.
Yeah, I think you're right. Like, just forgetting any other domains, but that one of the things that's fascinating about AWS is that there's a new way of developing software. And if you were using, let's say, Ruby on Rails or Django or these like object relational mapper style, solutions, that they had a period of in the history where they were very, very successful. And, the author of Ruby on Rails just recently talked about, switching from AWS. And first of all, I respect the DHH quite a bit. I mean, he's runs a successful business, very talented software engineer. I like his business advice. I think a very interesting and talented and successful person. I think if you 100% listen to, but I can't always agree with 100% of everything even a talented person says. And I would say that when he talks about moving from the cloud to a physical data center, and then he showed the relational database bill, the very first thing that comes to mind is, well, do you need the relational database to be used that much? Because if you didn't use an object relational mapper and you maybe tried some cloud native techniques or re-architected things and even used a language like Rust, I don't think you would even care about the server cost. And so I think this is a very interesting dilemma, is that as we move into new technologies and new platforms, that people may have to make tough decisions about should I do new things.
Yeah, and your example is great. You talked about Ruby, and the latest supported runtime by AWS Lambda is for Ruby is 2.7, and obviously we are way like upper than 2.7 version. So we could guess that AWS Lambda is not betting on Ruby, anymore. I'm not sure. I'm not working at AWS, but like the latest supported runtime for Ruby is 2.7, and I think we are like version 3. I'm not sure. I'm not a Ruby expert, but it tells a lot about what would be the strategy. And I guess I'm not saying that writing Ruby on Lambda is a bad idea, but obviously the runtime support is not up to date yet, and it makes more sense maybe to switch to a compiled and very performance language. Of course, it depends on the use case. If you don't need that performance, maybe there is no way no need to do that. But if you're looking for a strong performance, yeah, I would advocate for Rust.
Yeah, and I think one of what you brought up earlier, one of the things that's interesting about Rust is that you know I have actually personally programmed in C, and I wrote commercial software and mostly Objective C, but I got paid. Like I got paid to develop my own applications, and I really am not a fan of C. Didn't enjoy it. Like I think it's very unpleasant. Personally, I think there's people that are obviously really good at it and they enjoy it. But if you look at a language like Rust, or it's so different than C or C++, in my opinion, because it's a lot more like a Python, because it is concise. It has modern, techniques like immutable variables, for example, is amazing,
Yeah,
right? And then the ecosystem as well is, in my opinion, better than Python, because with Python, I typically what I do is I install a linter, I install a formatter, I install all these tools, and then the packaging. There's always at least two ways to do it, maybe three, four ways to do it.
yeah,
But if you just install Rust up, you get everything, and the tools are, in my opinion, so much better than Python tools because of the fact that it's a new technology
yeah,
innovation, right? Like if you look at again, we go to the 1970s Ford Mustang. Like at the time, like a four-barrel carburetor was amazing, right? Like, oh, this is awesome, my car is so fast. But now people, they don't want to burn gas as fast as they can. They
yeah,
want to burn no gas,
yeah,
right? And I think it's a similar thing is that when you use something like Rust and you realize that a lot of the problems you face in production are the packaging, the performance, and also the safety.
yeah. And yeah, and speaking about safety, I believe that by learning Rust, I believe that everyone should at least learn the basic of Rust, because I feel that it makes you like a better developer because you're really understanding what's happening. I'm sure you can relate, but when we start learning Rust, like the compiler is extremely verbose. It does not let you anything. So if you like spawning a new thread and trying to pass a variable into that thread, it won't work. And then you're like, oh yeah, actually that makes sense, because it does not make sense to do that. And actually it's kind of sad to think about, oh yeah, I had to wait for maybe 10 years to actually realize what's happening downside on the stack when you create a new thread and you pass in memory, or like you really need to think about who owns what, the borrow checker, the immutability that you talked about. I think those are great concepts. And when you start to think about that, I think it makes you a better developer. I don't know if you would agree with that, but
Yeah, I agree because there's like a difficulty versus um, outcome relationship where the ideal scenario is that you have enough difficulty that you get a reward for it, and you see this for life. Like if you want to get in really good physical condition, you unfortunately you can't do only low intensity exercise.
that's okay.
Excuse me. So you can't just do low intensity exercise, because there's different um, energy pathways in the body. So the anaerobic pathways in your body don't get triggered if you're just walking, right? Like walking is great, but if you want to, let's say, lower your resting heart rate significantly and get benefits for, some of the anaerobic benefits of exercise, you have to actually go at close to 100%. And there's a lot of research that shows this. Same with exercise with weights. So if you lift only like 10-pound dumbbells and you're just doing lots of weights, it might be good for just flexibility or something like that, but you don't build any strength because you have to go at a high enough intensity.
Yeah,
On the flip side, if you just torture yourself constantly and just you're going at 100% every day, your body will just be destroyed, right? So there's like a balance between
Yeah.
some suffering and some difficulty and intensity, and then the right outcome. So the same with programming. You could make the argument that maybe C++ is the suffering for many people is not helpful, like for what they get out of it. Like maybe there's some people that do enjoy it, but Rust is right in the middle where you're right. Like, the compiler is telling you a lot of things that maybe initially makes you upset, but then what you realize is actually I should be upset.
Yeah, exactly. This is, yeah, you could not summarize it better what I was thinking. Yeah, this is exactly it. Yeah.
And another thing that's interesting is staying on the Lambda topic. One of the topics that I'm very, very interested in because of the size of the binaries of Rust is could you even replace containers for some scenarios? Because, for example, Lambda is written in Rust,
Yeah.
correct? Right? Like,
I don't know that.
yeah, it is. So Lambda is Rust. So basically, it is running the Firecracker VM, which is you can just go to GitHub and look at it, and
That's
that's it, right? Like but the idea that you always need to use a container. I mean, there's some nice things about containers, but container adds some level of
yeah.
abstraction and some additional performance hits. Now, for a language like Python, you really have no choice. I mean, because of the fact that it's an interpreted language, deploying Python without a container is very scary.
Mhm.
Very scary because the complexity of getting the packaging right without a container is almost impossible
Yeah.
repeatedly. I mean, people can do it, but you have to use lots of very inefficient tools. But if you think about Rust, you in many scenarios may even consider not using a container, especially with something like Lambda, because you're like, wait, I have everything in the binary. Why would I also add a container?
Yeah, you would need to be very careful to the target architecture,
Yeah.
because obviously if you build for x86 and you're running on ARM, this won't work. But yeah, beside that, I won't see any downside of using a binary. Maybe containerizing your application is useful when you do like local development, thanks to the Lambda emulator runtime, which
Mhm.
is like a container provided by the AWS team to emulate the Lambda API runtime. Use /next /invocation response /errors. So by having a container, maybe it will ease the developments. But I believe that we tend to, because when you're using the cloud, people tend to like having locally everything. But maybe we should start to think about like maybe another availability zone is your sandbox,
Mhm.
instead of doing like local testing on your machine, trying to replicate S3 DynamoDB like in with test container or something. Maybe you should try it directly online, like put that on the cloud, on the sandbox account, and this is your dev environment. Because um, we usually say that development and production environment should be very similar. So if you're trying to debug and test locally, maybe that's faster, but you may not find some critical issue that you will encounter on the cloud, because obviously Lambda runtime is very different on the cloud from that provided container. So it has some difference.
Yeah, I prefer to develop, I mean, more towards the cloud-based development environment. So I do like AWS Cloud9. Have you played with that at all?
Not yet, no.
Yeah, it's pretty good. It's basically similar to what you're saying, where you can actually get the a very close to production environment because it's using Amazon Linux. The SDK is already installed and it is role based as well. So whatever role you launch the the Cloud9 account into, it'll assume that role. So it has some very strong benefits. And then because you're able to be in the same data center, right? The deploy speed to
Yeah.
push something is fast, like
Yeah.
very fast, right? So to your point, I think that's one. The other one I like to use a lot is GitHub Codespaces,
Mhm.
because Codespaces, I guess the biggest benefit to me is that I'm now hooked on the Copilot tool. I almost can't write software now without it because I find it so useful.
Yeah, and it's also benefits as a team. Like if you're like if in your team there's a lot of different contributors, by having code space or at least some other shared environment, development environment, you're sure that on day one, someone who comes to your team can be super effective on day one. So yeah, this is a very interesting concept. I definitely agree that as soon as you have to install yourself, you CLI, your build tools, it's not convenient for another team member to join and, oh, which version are you using? I have a bug on my machine, but it's not on the cloud. So the famous sentence like, oh, it's work on localhost, but not on the cloud. If you're starting to build directly on the cloud, it's also very useful for your CI/CD pipeline because
Mhm.
obviously you need a very strong CI/CD to be able to reduce the time between you typing a line of code and you'll be able to test it like on the cloud. So yeah, we sometimes underestimate the power of the CI/CD, and I believe this is really really important when when you want to make fast and efficient development.
Yeah, and I agree with you that the CI/CD is a topic that sometimes people don't totally understand. And so I've been teaching part-time for the last several years at universities. Mostly I teach now at Duke, and sometimes I'll have a person who has no experience with being a software engineer. If I teach CI/CD, it's very common for students to say, "Why are we learning this?"
Yeah,
And what I say to them is that because this is exactly what you have to do on your first day at work.
yeah,
Like any professional software engineer, if you don't know how the CI/CD pipeline works, you're not going to be successful.
yeah. And the number of errors or linting errors that the CI could stop from you to do it. It's unbelievable the value of CI, CD of course also, but CI is yeah, you're right. It's super important. If you don't have CI and you build like locally on your machine, like upload I don't know, a layer or like a Lambda function like on the AWS UI, it definitely won't scale. So yeah, be sure. Yeah, that would be my advice. Be sure to invest on your CI and CD like as soon as possible. Like maybe if you want to try to build a AWS Lambda function in Rust, maybe start by CI/CD, write a just small hello world Lambda function with no permission, just deploy it, and once you have your CI/CD, then you can start implementing your business logic.
Yeah, I agree. I mean that's the right way, and it's similar to the concept of the compiler, because that I think a lot of times people mistake progress for moving in the right direction. So if you temporarily make false progress, it feels good. Like, look, I'm programming in Python. This is wonderful.
Yeah,
But then to your point, like if you all of a sudden realize that, wait a second, my code, even though it runs, it's a ticking time bomb because I have redeclared variables, or I have like multi-threaded issues, or or whatever it is I have in here. And in fact, it would never pass CI/CD as
yeah.
well. So it looks like you're successful, but it's actually a fake success.
Yeah, and if you stop your project and you resume it like 2 months later, you're like, wow, where are my source file? Like it's a 12-factor application. It's CI/CD is one of them, I guess. I hope. I'm a big fan of 12-factor. Maybe there are some more, but yeah, it's part of that, and I believe that it's a very strong base for software development. Yeah.
Yeah. So the other thing that I was going to bring up about the small binary size is that one of the emerging issues in the machine learning operations space is that there's a bunch of new standards starting to come about. Like, in one of the things that I've seen quite a bit is that people want to deploy pre-trained models. And so maybe they have a Hugging Face pre-trained model, or there's a format called Onyx. I don't know if you're familiar with
To be honest, I'm very far from machine learning. Like it's not my field. I really like it, but I'm total noob in
Yeah.
that field.
Well, what I think is interesting though is that I believe that what's going to happen in 2023 and 2024 is that more people with your background, like who are software engineers, that they're going to take on a lot more machine learning tasks, because I think the delta between someone with your background being able to deploy a machine learning model versus someone who's a data scientist is like night and day. Because the skills you have are much more suited, in
Mhm.
my opinion, towards making production machine learning systems. Because if you let's just take the conversation we had, where if you want to have very tiny binary with fast startup time for Lambda, that's exactly the problem that people want to solve for MLOps, right? Right. Operationalizing machine learning is they want a very tiny pre-trained model that, if possible, as tiny as it can be, and maybe it's only batch or it's event based, and there are very tiny models. Like, you don't always have to use the most powerful model. You can use some that are maybe like a little bit smaller than usual, and as we get better and better formats that can shrink the size, I think solutions like Lambda could actually make sense.
Yeah.
Yeah. So I think that's an area that I'm very interested in, because I feel like there's a couple different targets that Rust could hit. Like, one of them is Lambda. I think people could be using more Rust-based pre-trained models in Lambda. That's one. And then the second is, one of the benefits of Go and Rust is that if you look at some of the really popular new tools, like Hugo is a static website generator.
Mhm.
I like Hugo.
Yeah.
But why is it so popular? Because grandpa and grandma can use it. You
Mhm.
just download the binary. There's no like, do this and click this install and then
Yeah.
install this other, like for example, sometimes when I work with Node, I get so angry because it's been years since I do something with Node, and then I have to do something in Node. It's like, oh no, I have to install this install tool, then another install tool, then and then it's like 2 hours later, then finally you get it working. If it's a binary, there's nothing to install. You just pull the binary and you just run it. So similarly with machine learning, I see a huge opportunity for people to do, like you said, CI/CD, but to do CI/CD for command line tools that
Mhm.
have embedded
Yeah.
the machine learning model.
Yeah, that's a good point. And yeah, since you're talking about CLI, like Rust is a great tool to build CLI as well. So I've built one, and it's really easy. There are a lot of different lib to create very simple CLI tool, and it's a perfect use case. It generates a binary. You can even embed that in a Docker container if you want. So there is nothing to install. Of course, you will need to have Docker, but yeah, that's powerful as well.
Yeah, so that and I think that's a very big difference from Node, Ruby, or Python, is that you can't just give someone like your CLI.js, right, or your CLI.py, unless it uses only the standard library. But if it only uses the standard library, it's almost useless.
Mhm.
So most of the time, people have to use an installation
Mhm.
tool, and there's competing installation tools. But the really the innovation in many ways with Go and Rust is that basically binaries are now, I think, potentially once again very popular. Like, people might go, why don't I just make binaries and
Mhm.
just put these packages onto GitHub packages, and then that's how I share my tool.
Yeah, the only downside would be a security aspect, because of course, if you have access to the source code, you can inspect it before running it. If I provide you with a binary, maybe you would be a bit hesitant by running it. So I still a big believer in open source contribution and open source world. So yeah, maybe a piece of advice: if you want to run a binary, make sure either you look at the source and you compile it yourself, just to make sure that you know what you run, because like
Yeah,
by
that's true. No, you could make the argument that also the same problem exists with the interpreted language, because sometimes they pull in things and they could have the wrong dependency.
oh
I,
yeah, yeah.
yeah, but I think one of the ways that you could solve this problem is that if people can see your build system, right? Like, because you can look inside of open source GitHub project and they can literally see that the binary was pushed from GitHub, like, and they
Yeah.
could look at the last build
Yep.
and they could see the compilation, and
Yep.
then you could even print the checksum,
Yep.
right, of actually the build, and then that checksum is the same checksum that's
Yeah.
actually in the
Yeah.
package.
Yeah. This would require to build from official Docker image and not
Yeah.
some fancy custom made Docker image, because obviously you could tamper with cargo or with a building tool. But yeah, I do agree. Yeah.
But yeah, in general, I think there the and even for production, one of the things that I think is kind of interesting is that in the old days of Unix and Linux, there was more of a emphasis on centralized file system. And I worked in many environments where we had NFS, and there would be huge NFS, like petabytes and petabytes of NFS, or 100,000 NFS users. When I was at Caltech, this was almost 25 years ago, when I was in IT there, they had, I think, 50 to 100,000 users just on NFS.
Yeah.
But there was, that kind of went away with cloud computing. But now we have actually some very sophisticated managed file systems like EFS on AWS. And then now the binary, again, is kind of interesting,
Mhm.
because if you could, your deploy process could be simplified, where you use code build or you use GitHub Actions, whatever, and it's literally rsync, or CP or whatever, and you just put the binary on EFS.
Yeah.
And once it's on EFS, I think can't Lambda now? I haven't done this. Can it now mount EFS?
I'm not sure, because what you can mount, you have to deploy it as a layer, and it will be mounted under /opt. I'm not sure you have access to file system, or I'm
Hmm.
not sure, to be honest. But I would say no, but this needs to be fact checked. I'm not sure.
Yeah, but forget even Lambda for a second. If you did need to use a virtual machine, for example, that, because I've done this before, is when the virtual machine starts up, it just mounts EFS,
Yeah.
and if the binary is in its path, and it's maybe your bash RC just sources,
Yeah.
that binary,
Yeah.
that's it. Your deploy process, there's nothing to do.
Yeah. Yeah. What you can do with AWS Lambda is to play with LD preload, which is an environment variable where you can like intercept libc calls. So you can do like very funny things, such as you could replace a random function to return always 42, for instance. So if you're deploying like a Node.js Lambda function which use maths.random, for instance, it's likely that the libc call underneath will be triggered and intercepted by this LG preload library, and then rewrite it. So there is a cool crate in Rust to do that as well. That's
Oh,
funny.
yeah. What is it called again?
It's LG preload. It's
Oh,
like an environment variable where you can set it to like a shared object file. You can build that in C
wow.
or in Rust, for instance, and it can intercept libc calls. So of course, if you're using Go, there will be no such things. But if you're using Node or Python, you can intercept I don't know, like open, close, read, write, like those basic C or libc function or
Hmm.
entry point. That's funny to do.
Yeah. Wow. That sounds. Yeah. I think. I mean, the just when you start to dig into the interpreted language versus compiled language problem, is that one of the issues that I have currently with Python is that for years and years and years, maybe 15 years, I think, when they were writing Python, when they went from Python 2 to Python 3, I don't know if you are remembering this, but during that time, people actually did ask about the global interpreter lock. They said, hey, maybe that's a good time to fix it in like 2005 or
Mhm.
2006. And I think the consensus was, well, you don't need threads, that they're not important. And then another thing that people said was that, oh, most of the time all code is slow because of IO. And I think what we're seeing is that's just not true. That you're when you say that, you're basically creating a fictional reality based on the capabilities of your language.
Oh
Like
yeah.
you're just reverse engineering what your language can do and then making reality match it.
Yeah. If you're IO bounded, it means that you've done a great job while coding. But to be honest, like I've been working with profiling tools for a long time now, and usually it's due to like string manipulation, wrong data structure, like inefficient sorting methods, and invalid, useless code to be not lazy loaded, and so on. So yeah, if you are IO bounded, that's a good problem to have. I believe this is because like you've optimized everything else, and now you have a new issue. But yeah.
Yeah, and the other thing I think that's interesting about the Rust versus Python problem is we haven't really talked about it that much, but the energy efficiency issue, which I mean, the proxy is basically CPU time, right? Like obviously, the more CPU you use, the more energy you use, and there there are many organizations that have sustainability targets,
Yeah.
and I think one of the things that they could 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 consider is, could they replace maybe microservices that are running in production in Python or Ruby in particular with Rust, because that would help them meet their sustainability goal.
That's a good question. Yeah, that's very good. And the cool thing about that is sometimes companies don't see very like, it's not that they don't want to reduce the footprint. Of course, they all want. But the cool thing about the cloud is you pay as you use. So it's one more in one more argument to say, hey, let's try let's try to be reasonable about the resource we use. So obviously everyone should do it, but I believe that since there is money behind that, I think it's a good incentive for companies to start looking at that. Yeah, you're right.
And if you look at the data engineering tools that are the new generation, there's several different iterations of data engineering tools where Hadoop for a long time was popular, but in my experience, almost no one used Hadoop, right? At companies I worked at, the Hadoop was always broken, and then people would just go into a SQL database and just fix some things.
Mhm.
And then the Spark revolution really was helpful because they were able to build on top of Hadoop and make it more useful. And you see, like, there's commercial products
Mhm.
that now that do manage Spark. But if you look at really kind of dig into the architecture, it is a very inefficient architecture, which is you have virtual machines just grinding away at,
Yeah.
like, sending data back and forth to, like, storage systems, and then you look at the language on top, it's going from Python down to Java, and the whole thing is seems so inefficient to me based on my experience with it. But then if you look at the newest forms of data engineering tools, a huge percentages of them are either written in Rust or written in Go.
Mhm.
And so I think that's another area that could be interesting for companies, is to dig into the stack and say, what tools can we replace so that we properly use the cloud?
Yeah.
Right?
Yeah, definitely. And you're totally right. And also we didn't talk too much about that, but I believe also to review code, like for you talk about Go, but with Go, I have nothing against Go. I'm not into like runtime wars. I don't do that. But for instance, in Go, you can spawn two Go routine and write to the exact same data structure. It's very hard to detect while you're doing like code review because yeah, you can run with dash race and it could detect some potential race condition. But this is not the case for Rust. So you can compile it so the CI won't pass if you are spawning two threads trying to write to the same data structure. So I believe this is one more advantage over Go, maybe because I know Rust and Go are producing binaries, but this is why maybe I would aim towards Rust because it might be harder to develop, but it's maybe easier to review. You have a lot of very solid static checker. You mentioned Rest Up. There is also Clippy, Cargo, FMT. Um, they're catching a lot of different errors, and uh, I think using Rest is really helpful while reviewing code. You know, if it compiles, the big change that it won't panic at runtime. This is like Rust guarantee. Of course, there are some exceptions using unsafe code or accessing out of bound exception in an array, but there are some ways to deal with that. Whereas in Go, I believe it's easier to introduce a panic like very subtly in a PR, and no one could catch it. And yeah, so
Yeah,
that's
yeah. I mean, I agree with you. I try not to go too much into like one language versus
oh
another.
yeah. It's just
But I do agree with you that if I look at Rust code, I look at Go code, I think the Rust is very readable to me as well. And I think the style that you're developing in with Rust, because you can trust the compiler so much, it really leads towards efficient code. And then also it leads towards um, like you said, like safety, and a huge issue right now for companies that are using cloud computing is cybersecurity. And it's almost every day you hear, a new company got hacked, and that's another reason why organizations, I think you can't just say, well, we used to do it this way, or the most popular programming language is Python. Or I hear sometimes people say, oh, well, it's not that big of a deal if your code is slow. You just mix Python and C. But it's like, well, sure, you could do that, but why don't you just use one language that has very strong cybersecurity, very strong performance, very strong, code review, like, and that's where I'm with you that Rust is quite compelling,
mhm.
and I think we're going to see many people get on board. I mean, it took me a few months to really understand, and I realized like, wow, this is a very big deal.
Yeah, and Chrome has just announced that they're using Rust into their code base as well. I'm not sure if it's Chromium or Chrome, but one of the two. Unix is embedding Rust as well. So yeah, it's very promising. I think more and more developers should definitely at least have a look at Rust. Maybe you won't like it, but yeah, I would suggest at least to have a look at it. Give it a try.
Yeah, and also in terms of machine learning, one of the things I've been playing around with is that the most popular deep learning framework is PyTorch, and the bindings for Rust are very good.
Oh
Like,
yeah,
and I've been able to, use pre-trained models. I've been able to use the stable diffusion with PyTorch. I've been able to train deep learning models with Rust. I've been able to use GPU PyTorch. No difference in my opinion. I
cool.
mean, maybe slightly, more bleeding edge, but if somebody wanted to do high performance deep learning
Yeah,
and get all of the benefits of Rust, my experience has been extremely positive for PyTorch Rust.
nice, cool.
Well, yeah, I think we covered a lot of really cool topics. Is there anything else you wanted to share with people, or give them links to things, or other
Yeah,
people?
yeah. If you can give the link to my new YouTube channel, I'm trying to do to showcase how you could use Rust. So, for instance, the new video will come with test container and Rust and how to really test
Perfect.
your different things. I've created a video about how to develop a AWS Lambda in Rust, GraphQL in Rust as well. So, yeah, I'm trying
Nice.
to contribute to the community and to share my Rust enthusiasm. I would say.
Yeah, well, we could even just throw it into this chat, and I'll also put in there like what is your channel, or if you throw it into the comments right here, I think.
Okay,
And
let's me do that
yeah,
in the chat here.
yeah, I think if you throw it in here, it will go to multiple locations.
All right, I've just pasted it. Oh, in comments maybe.
Oh yeah. So let me copy this. Here we go. I'll put it here. Yeah, comments exactly. Yeah, and then we just throw it right here, and then I'll also put it into places when
Yeah, that's
I
awesome.
share. But it's, yeah, that's great. I think we need more people evangelizing the Rust solutions, because I think people feel a little bit overwhelmed. They're like, oh, it's so hard to program with
Yeah,
Rust. But as to your point, I think as people start to realize that you can build pretty much not only the same things you can do with an interpreted language, but in fact a deeper selection of choices.
yeah. And yeah, I would conclude maybe by saying it. Don't be shy. Try. Of course, you're not going to be a Rust expert. Like, I've started to learn Rust like 6 months ago, so I'm definitely not an expert yet. I hope to come with more and more experience, but you should try it. Of course, no one writes perfect code, so yeah, just try, experiment. If you have time to share to the community, that's wonderful as well. And it's great if you want to contribute to open source repo in Rust. That's a good way of learning Rust, to get feedback from real experts in Rust. That's a good way also to learn more and to be better at what we're doing every day. So yeah.
Yeah, I agree. I think there's no better way to learn a language than to just make stuff.
Yeah.
And you're right. Like, so we probably have a similar amount of Rust experience. And I felt like I try to make a few different projects every week. Sometimes I get 3 or 4 projects in a day, but generally I'll maybe like make a few different projects in a
Yeah.
week. And it's just that's how I learn. It's just
Yeah.
more I'm just going through and I'm building stuff.
Yeah, and yeah, just read the doc, read the blog. I'm still discovering a lot of different things. So last week I've discovered that an empty vector will be evaluated as none. So there is no point of writing an optional vector if it's empty. So it's small tricks, but it's good to keep learning. Like every day, I feel like I'll learn, and I want to keep that way.
Yeah. There's some stuff that I want to learn that I haven't played with yet in Rust. Like, I would say tracing, I've only played a little bit with, but I want to get better at tracing. I also want to get better at the benchmarking. There's some tools that you can look at the calls and see, what's slow, like, like a heat, like a one of those heat map type tools. Have you played with some of those?
No, but it's definitely what I like the most about new languages is look at the performance, CPU performance, and timing performance. So yeah, I would definitely have a look at that.
Cool. Well, yeah, it was great talking to you. I'm sure we'll talk again in the future.
Yeah,
Hopefully I was able to share you with a wider selection of people, and they'll
well,
subscribe to your channel and
that's
go
that's
from there.
that's very nice from you. Thank you so much for having me, and yeah, I have a lot of fun explaining what I'm doing and what I'm believing. Maybe people won't agree with me, but that's life. So yeah, thank you so much, and have a very good day.
Okay, talk to you later.
Bye.
Bye.